Hello and welcome to your 18th tutorial. So let's open up. Now today we're going to be doing two things. First of all is putting on gizmos on our waypoints, and the second of all is getting the enemy to follow the player. So first off, we'll need a gizmo image to put on there. So let's open Photoshop. Now you can do the image however you want. You can do whatever image you want. I'm just gonna do a quick image here. Just make sure the image is in a small resolution, because the resolution of the image that will be exported is the resolution of the image in the editor. You can't control its size, so just make it a small size, because that's what we want for now. Yeah, that's really small. Got 500. Great. Select the color. Awesome. Let me just like that. Yeah, I want a little neater X maybe. I don't know, you get the point. Yeah, so once you've got your image, save for web and devices, save, and we'll call it waypoint. Save it. Now I'm going to show you how to import things out, to import anything into Unity. All you do is simply drag and drop in the projects window. That's all you do, and then it's in your project and you can use it. Now its icon here, its icon over here is gonna look messed up. It's not gonna look anything like the real image. This is the real image, so ignore the little drawing here. Now to use it as a gizmo, you know, you can't just reference it to any image. You have to make a specific folder. It must be called gizmos. You must do this. There's no other way to put gizmos on. Then you take all your gizmos and you put in the gizmos folder. You must do this, otherwise you cannot have any custom gizmos. You'll only read from a folder named gizmos, and that's it. So now we need to create a new script that will put the gizmos on. So let's just call it gizmo, right? Per creative name. Let's attach it to each one. Great. Whoops. Wrong script. Let's open up gizmo. There, perfect. Exit that, and just what we need. I don't want the function update. We want on. I forget how it's called. It's something with on gizmo. Let me just check real quick. Unity3d.com. Right. Sorry for not remembering. It's just a bit complicated. Well, what is this? Alright, that's the site we want. So let's just go in the... Whoa, they made some changes. Alright, documentation and scripting references. Nice. Alright, I want to type here gizmos. Hold on, wait for it to load. Yeah, I have pretty crappy internet, if you don't know that by now. There we go. Gizmo. And go to draw icon. There, on draw gizmos. That was pretty simple. Right, now I want you to copy this. If you don't have it, if you didn't go to the webpage with me, you can copy it from here. Give it a second to copy it. There now. And here we don't want the light gizmo. We want our own custom gizmo, which is forget how I called it. waypoint, I think. You must also tell it what file extension it is. And I'll save that. And there we go. Right, so let's test that out. Oh, whoops. There, see? Should have made the image a little smaller, but that's our gizmos. These will show us wherever there is a waypoint. Now just to show you how the enemy goes between the gizmos. Oh, left me firing there. Alright, now to the enemy. Open AI waypoint. And now we're going to do this in another way, detecting it if the player is near us. Because in the previous way you did with raycast, and now I want to show you a different way to program AIs. And you know, I want to do this. You could do this with the raycast, it'd probably be better. But I just want to show you more options to programming with AI. So it's not all raycasts. So what you do is you basically, here we're going to program our AI according to the player. So first we'll need to reference it. So var player equals, then we want to find the specific game object. I'm going to use a function called find with tag, and this finds it by tag. That's how it's done. It finds a game object by a given tag. So player. Great, and now we want to access its transform. So now that we have referenced the player here, we want to calculate distance and direction. So var dist equals vector3 dot distance, player dot position. The reason we don't need to type player dot transform is because we already typed it here. And then it transforms position. Great. And just maximize that. After we've calculated distance, we will need to calculate direction. So var, we're going to use a function in vector3 called dot. So var dir for short equals vector3 dot. Then in here we want to put player dot position minus transform dot position dot normalized. And in here we just want to put, I think, forward. I'm not sure. I haven't done this a lot, so yeah, we're not getting any errors. You know, let me just double check that. I've already typed the script somewhere else, so let me do that. This is another project I'm working on. And direction, oh, forgot transform that forward. Whoops, there, control save. Sorry for that, I'm a bit forgetful today, I don't know. Alright, now once we've got all that, we want to basically check what's happening with that. So first we'll check the distance. Now here we'll make a variable site range. I already made it, but make a var site range like that equals, by default, 15. I'll make it a bit small for now because we're in a small testing area, but I can change it. So if distance is less than site range, open brackets. And now here we want to check the direction. Now the way to check the direction is this will return a float, and it will return a number, a float number with either, you know, it will return a big range of float numbers. but we only want to check if that number is bigger than 0 and smaller than 0, because bigger than 0 means it's in front of us, and smaller than 0 means it's behind us. So I'll just type there is less than 0. So if it's a negative number, then he is behind us. So excuse me, bigger than 0. And yeah, well, I think I'm not sure if the negative is behind us or what. Well, let's just try that out first. So if direction is less than 0, then we want to set is attacking equal to true. Right? Now, once it's caught sight of us, it'll keep looking at us. So if, and I'll explain in a minute why I'm doing it this way, not in the same if. If attacking is equal to true, you don't have type equals true because it does it automatically. Then look at him. There. Well, the reason I'm doing this is I don't want to do an else on the direction, and if he's out of our direction, then just look away. I want to keep looking at him until he's out of range, not until he's out of direction. So I'm just gonna do if he's still attacking, then check the range, and if the range is, if he's really out of range, then set is attacking to false and don't look at him. So let's do that. Else is attacking equals false. Great. Yeah. Well, that's pretty much it. I think this should work. Just need to take the player a bit back and maybe rearrange our waypoints, you know, so we know when he goes back to his waypoints. And also notice we made if attacking equals false here. So yeah, right, he's going between his waypoints undisturbed. Now if he's there, he's caught sight of us, and whoa, he's way too fast to escape. So yeah, let's narrow that down to 3, because we want to test if he loses sight of us ever. See, we didn't need to be in a straight line, we didn't need to cross a straight line, we could just be, you know, in his front side. So it's much easier to get detected by the enemy now. And notice he'll be following us, and if we're out of sight, he's back to his usual algorithm, bouncing between waypoints. So yeah, that's all for this tutorial. Now I want to point out one more thing, that in the AI gun script it will not work anymore because AI move does not exist. So in the next tutorial I will show you a way that you can get a certain variable from scripts without defining their names. So you'll see how that works. You see how that is logical, because I know it kind of sounds, you know, illogical right now. So that's all for now, and bye bye.